welcome to your ESC demonstration. I'm Phil and I'll look after you for the next couple of minutes. The idea of the exercise now is to get a feel for how ESC intervenes in a critical situation. We're going to drive through a critical situation twice. The first time with the ESC switched off. You can't do that as an end user. We've broken into the ECU in order to help demonstrate that this is a stable vehicle, but also how important and how effective ESC is when it's switched back in. So you can get a feel firsthand of how these systems operate, what they do it and how they do it. In order to have ESC, you require ABS and traction control. So these vehicles are fitted with both of those things. There's also, that gives you the wheel speed sensor from the ABS, an accelerometer, a G sensor, linear one for the traction control, and we now have a yaw rate sensor, which is a G sensor across the vehicle, and a steering angle sensor. These sensors are monitoring the vehicle's progress 25 times a second throughout the time that you're driving the vehicle. It has no personality, it's not thinking about what's ahead. All the system is doing is recognizing if the vehicle is going where the driver's steering the vehicle. If that's not the case, it will intervene. And I'll talk more about that when you feel the intervention. But for the time being, we're going to drive into a critical situation. Perhaps a child steps off a pavement in front of us. We're going to use about 40 miles an hour. Okay, here we go.
It's a 6-point harness.
So we'll use a normal road speed, 40 odd miles an hour nominally. It's not critical, it'll work at any speed. It's just that that's a nice one for us to enable to demonstrate the situation. So about 43 miles an hour. All of a sudden someone steps off the pavement and we have to steer around them. And clearly the vehicle didn't go quite where I wanted it to. As a driver, I was out of control. The vehicle had lost adhesion with the ground and we're in a spin. Now, the whole point of ESC is to try and avoid that spin occurring in the first instance. If we can do that, we're less likely to hit a queue of people waiting for a bus. We're less likely to hit a tree or a pillar box. We're less likely to clip a curb, all of which could have dire and disastrous consequences. So shortly, we're going to do exactly the same exercise with the system switched on. I'm going to endeavour to drive at the same speed, with the same steering inputs on the same surface. We should see quite a different outcome. So this time we'll use the same speed. The ESP system is switched on. Martin's safe and clear, so out we go. I'll try and recreate the same speed, just over 40. I think we're about 42, 43. Same surface conditions, same steering inputs, all being well. So we cruise into our critical situation, happily minding our own business. Everything's well with the world, and all of a sudden someone steps off the pavement in front of us and we have to steer around that obstacle. Now, you felt the brakes applied. You heard the brakes applied. I went nowhere near the brake pedal, didn't touch it once. I'm not suggesting for a minute you shouldn't in a critical situation. What I'm trying to demonstrate is that this is an active safety system. It does not rely on the driver braking in order for the brakes to be applied. It will brake individual wheels independently of the driver in order to help steer the vehicle. A bit like fiddle brakes on a tank or a knackered shopping trolley with a wobbly wheel on it, the one that we all park because we can't get to the aisle we need to get to. So what the system's doing is very straightforward. The way it does it is very complex, but we don't need to know about the complexities really. And there you are. ESC does exactly what it says on the tin. Rude not to have it.